Remember to hit record. Okay, before we start with 11.1, I wanted to talk about statistical significance versus practical significance.
So we are on 11, you said, or what? Where?
We'll be on 11 shortly.
Oh.
We're going to do 11.1 today. We'll do 11.2 and 11.3 on Thursday. And we'll be all caught up. We'll have three sections left to do. One per day. The rest of the semester, other than Thursday, can be like a nice, just an hour worth of chat. Give you time to, what?
What's it called? Projector?
What about it? It's not down?
I asked.
Did you?
Yeah, I was like, do you want me to get that for you?
I've already getting up. After I've been sitting up there and no one said anything. F. Here. Here you go. All right. So, N is really, really large. Our hypothesis test results we end up seeing that the p-value is less than alpha. And that's a reject H0, support HA. But N is so large that the actual values may be really close. But the N is making standard deviation super small. Super duper small, like really small. And so it looks like our value isn't close to H0. The reason why whenever we're rejecting H0, we're supporting HA, we find that the value that we are looking at is too far from H0. But with large N's, that's not the case. So while something shows up as statistically significant, the problem says, the hypothesis says we should reject it. When you look at the actual values, you'd be like, I ain't rejecting that shit. We'll do an example in a second. All right, you guys ready for the example? Wait, Herlinda is showing.
I'm not explaining an example.
What?
I was just writing the word example.
You're coloring? I'm so excited she's got to do coloring. She's like, your shit's boring, Jones. All right, so in 2003, the average age of a mother I'm going to say mom because it's shorter to write. At the time of her first childbirth, was 25.2 years old. Researchers think this is too low. Researchers think it is now higher. After surveying 1,200 mothers, surveying 1,200 moms, they found a sample mean age (25.5) with a standard deviation of 4.8. Do this test at alpha equals 0.05. And I will get StatCrunch up and ready to share. Recall what StatCrunch needs. We've got a one sample test. This is a one sample mean test. Our H naught is the previous value, 25.2. And our HA is, they say it is higher. The values they're going to ask us for is the sample mean, the sample standard deviation, and the sample size. You guys ready? Arlene, you good?
Yes.
We're going to go stats, T-stats, one sample. We don't have the data. We got a summary. And we'll just enter in what we know. The sample mean was 25.5. Standard deviation was 4.8. This was 1,200. Sample mean was 25.2. I'm sorry, the old mean was 25.2. And we're looking at greater than. Make sure I entered everything right. 25.5, 4.8, 1200, 25.2 and greater than. Okay. I click compute and it gives me a p-value. My p-value is 0.0153. And I'll write down the test statistic while I'm here as well. The t-stat is 2.165. So I'm just pulling the information I have from there. It's on here in red. We compare the p-value in alpha. The p-value of 0.0153 compared to alpha is less than. P-val's too low, we reject the HO, and we support HA. So if I were to write out the sentence that goes with it, we're supporting HA, the HA is the mean is greater than 25.2. There is sufficient evidence to support the claim that the mean age of mothers at their first childbirth is greater than 25.2 years old. We say this is statistically significant. Because it allowed us to reject H0. We said the old thing isn't right. That's the idea of what statistically significant is. We did the statistics on it and we found something that was enough to make us go, this is fishy. Now, let's really look at what the problem says. The old study in 2003 said 25.2. The new study said 25.5. Can anyone in here tell me the difference between a 25.2-year-old and a 25.5-year-old? A couple months, right? Is that really enough to go? The old shit's wrong. Like we're close enough. They're still just a couple months away. So while this is statistically significant, this is statistically significant. While the stats say it's different, in practice, we look at it and go, now. So her birthday was in February and not June. It's the same year, you know. That's the idea of statistical significance versus practical significance. You can go through and get it all the math, and it'll say, nope, we need to change some shit. The old rules were wrong. Whatever we had before, the H-dot was wrong. And when you really like dig into the weeds and you actually look at it, you go, is it though? Is it really? That's the idea of statistical significance. So there's a question, I think there's a question on that. It'll show up in chapter 10. Is this practically significant or is this statistically significant or something like that? Now, if this said 27, Yeah, that's not just statistically significant, but in practice, yeah. A 27-year-old is a couple years older than a 25-year-old. All right, let's take a look at chapter 11. Chapter 10, we were doing hypothesis test with one group. Chapter 11, we have two groups. These are on two sample groups, which usually implies there is a comparison going on between the two groups. .1, which we're doing today, covers proportion-based ones. So proportion test for two samples. All of our old rules still apply. Old requirements still apply. We need n times p times 1 minus p to be greater than or equal to 10. For both groups. They usually have different n's and different p's. And they need to be independent. i.e., one group doesn't affect the other. Like if you're going to compare guys and girls, don't use husbands and wives. They're not independent. One will impact the other, whether it's the wife has swayed the husband or the husband has swayed the wife. You never know. If we're talking about chick flicks, my wife has swayed me. If we're talking about action hero, superhero shit, I have swayed her. She didn't like them, now she does. And I will watch some chick flick shit and enjoy it. So like, but if you had asked me before I got married, no. I don't want to see some romance shit. Oh, I said that out loud. Maybe I should write it. Like, if you have guys versus girls, don't use husband versus wives. Maybe let's rephrase that. Don't use wives versus husbands. They're not independent. So we need that N1, P1 times 1 minus P1 to be greater than or equal to 10. And I need N1 to be greater than or equal to 0.05, sorry, of big N1, the population for the first group. The sample size for the first group has to be less than. How come I doing? Has to be less than 5% of the overall population. And the same rule applies to the second group. N2 times P2 times 1 minus P2 needs to be greater than or equal to 10. And the sample size for the second group should be less than 5% of the population size for the second group. Those are our base requirements. Everyone ready? Shelby, you good? All right, so a couple things. We need to know where to find it. So since this is a proportion stats, we're going to go to proportion stats. This time we're going to click on to sample. And we have three options there: with data, with summary, and then we have power sample size. There might be a fourth one. Power sample size. Usually we're doing one of the first two. Okay, yeah. Same thing. I don't think I've ever used it. So it must do something, but not like it's very specific. Now, what do we do for H naught and HA? In your head, H naught is P1 equals P2. The proportions are the same. And we can either have them, HA either be greater than, P1 is greater than, P1 is not equal to, or P1 is less than P2. That's not how StatCrunch does it, though. What StatCrunch does is subtracts P2 over. The StatCrunch way is H naught is P1 minus P2 equals 0. And HA is P1 minus P2. And there, this is where we can do the greater than, not equal to, or less than. And this value is actually editable. Default is 0, but can be changed. Why you might want to change it is you're like, yeah, I know group 1 is always has a higher score than group 2. But is it a lot higher? You can start going, how much higher is it? The mean height of men is higher than the mean height of women. It just is. But is it a lot higher? Or is it a little higher? We could do a proportion We could scale it there with that. Other than that, everything else is the same. Same steps for the hypothesis test. It's worth doing. Which is group 1, which is group 2. In fact, it's very important. If you don't do it on the final, you're going to get marked down. And do all the stack crunch work for you. One of your things is to tell me what kind of test it is. And when you get to one of these 2 sample tests, you need to tell me what type of test it is. It's a proportion test. And then you need to mark what way each one is. Because depending on which way I mark, like if I say P1, this is why I mark it. Let's say I say P1 is males and P2 is females. And we're talking about mean height. I would say P1 is greater than P2. And this turns into P1 minus P2 is greater than 0. If you have them labeled the other way, then females have a smaller height than men, and this becomes HA. It changes HA. And that's what the statement we're trying to write about. When we do our conclusion, that's the one we're saying we supported it or we didn't support it. You've got the wrong HA to go with whatever you're saying, you're going to have like the exact wrong answer. So very much do that. Know which group 1 is 1, which one is group 2. It also can't hurt to identify with, now that you've labeled them, N1 and N2. You probably need X1 and X2 as well. When you have a summary, they'll say this many out of this many. You guys ready for an example? For Linda? Ready?
Yes.
All right, so first example. An economist believes that the percentage of urban households with internet access is greater than the percentage of rural, I can't even fucking say that word, than the percentage of rural households with internet access. Rural.
You said it.
Fucking sounds wrong.
Rural.
I know.
It's just a fucking terrible. I'm gonna say country. Country household. That's what they're really saying. Urban, you're living in like in the city limits. Country, you're like outskirts, right? So I'm done fucking saying rural. I'm gonna. The one time I said just it flows off my tongue. I'm gonna say country for that. So what does he do? He takes random samples. The urban households has 800 homes. And 338 have internet, have the web. Our country households, there is 750 homes and 292 have the web. And our job is to test his claim at the 0.05 level of significance. What do you think, Tommy? Should we do group one is urban or group one is country? Is what? Urban. Okay. So we are going to say that urban is number one. Country is number two. He says urban is higher than country. Urban is higher, greater than country. So that goes like that, which means P1 should be greater than P2. And if I move it all to the left, I've got P1 minus P2 is greater than 0. That's going to be my HA. H naught is they are equal to. We've identified these values as group one and these values as group two. We need a test statistic. A p-value. And we have alpha equals 0.05 already. I think this was a good setup. I think picking urban greater than country is the way to go. I think it makes much more sense to read shit that has a greater than sign. It's weird to say something is less than another group. Always is to me. That just is in my head. You might have no problem doing the other order, but I personally always pick it so that it ends up being greater than. If I have to write it out and I pick wrong the first time, I rechange which groups I pick because, like, I don't know, when I read it, it just is confusing. Everyone good? You guys ready for some stat? Let's do some stat crunch. So we are going to go stats, proportion stats, to sample, and we have a summary of the results. Sample one was the urban. I marked that. Urban had 338 households with internet out of 800. It's automatically filling this in from 3 years ago when I did this example before. 292 examples with 700 out of 750 homes. And the economist said that the group one was higher. So I got to make sure I change that. 338, 800, 292, 750. Everything's looking good. I'm going to click compute. And it gives me a value. It gives me my Z-stat is 1.329. And my p-value is 0.092. This sample difference it shows right here is actually the difference in the two percentages. It doesn't say what P1 is, it doesn't say what P2 is, but it tells us that P1 minus P2 is the difference in their proportions, which makes sense. That's what subtraction does. And the difference that's in the samples that we have is about 3%. Back over to finish our hypothesis test. Now, if I compare my p-value to my alpha, p-value is not less than alpha, p-value is greater than alpha. So the p-value is not too low. We do not reject H0. Do not support HA. So HA was that urban homes had a higher internet access, and we can't support that. There is insufficient evidence to support the claim that a higher percentage of urban homes have internet access over rural homes. I'll go back to the word they used. I just went to country because I fucking saying rural just doesn't sound right. There's one, another one. Nope, I think pin's still fine. Patience.
For the realization that I think our group project should be our final. Is our final gonna be on everything or this one?
Just on hypothesis test. You don't even need to do the stack rank. Your problem, and you've already seen 3 out of the 8 hypothesis tests. We've done a one sample proportion test. We've done a 1 sample mean test. Today we did a 2 sample proportion test. Thursday we're going to do 2 sample mean tests. There's 2 forms of that. One where there is a link between them, where they're paired, and one where there isn't. There's only 8 tests. And it's all of it.
Just 8.
Yeah, you pick any other fucking class on this campus and they make you memorize more than 8 things.
I've had horrible math teachers. That's why I failed all my classes before. I think I'm gonna do all right.
Pick any class at this school and you need to memorize more than 8 different things for a final exam. The hypothesis test is identical. Every step we do is identical except for this H0 and HA. You're still getting the test statistic. You're still comparing them. You're still rejecting H0 or supporting HA based on it. So you just need to know how the general hypothesis test works and what this H0 and HA is based on the different types of setups. It's not that bad. Way easier than the midterm. And I'm pretty sure the final grades will reflect that. It's doable. Especially if you do your homework. And you practice doing these tests, and then you go, oh, okay, I get it. It's just really hard when you don't do your homework, Hansel.
I always do my homework.
Hansel, I don't know. Can I go look? Put your ass on blast.
I'm late in a couple.
We've only had 10 assignments. So you're late on.
I got 2. It's like 80%.
Next problem.
I was trying to figure this out.
Huh?
Trying to figure out chapter 11.
A group of COS students felt that there was a difference in proportions of female students that changed their majors versus males. Change being they've changed it at least once. Whether they've changed it 10 times or 1 time, doesn't matter. As long as they've changed it, it counts. Of the 80 females asked, "39 had changed their major. Of the 86 males, 51 had changed their major. Test the student's claim at alpha equals 0.05. Okay, one of these things, just other than it being in the section on two samples with proportions, when you're reading this problem, they are comparing two groups. They're comparing men versus women. So that is an indicator that this is going to be in the two sample, because there's men and women. Now, then they start giving values for the number of people that have it and out of the total. If it's going to be a mean one, the mean, they have to tell you what the average is. Here, they're just telling you the number of people that meet the criteria. That's kind of a giveaway that it's a proportion. In fact, it says proportion. So it says proportion and it lists two groups, tells you that this is a two sample proportion test. So we need to figure out what we're going to label P1 and P2. I kind of like to write what their claim is first, symbolically, and then go from there. It says there is a difference between females and males. Females are different or not equal to males. So here we're a little bit safe as long as we can't really fuck it up too much. We just need to pick a group. They talked about females first, so I'm going to put females first. I'll put males as the second group. Now, if they had said one was larger, I would have picked group one to be the one that's supposed to be the larger group, because then I end up with a greater than sign here. But when it's not equal to, good to go. So H naught will be like all H naughts for two sample proportion. And HA in this case, P1 minus P2 is not equal to 0. I'm going to jot down what they gave us just so I have it available. Females were group one. There was 80 females and 39 said yes. And for the men, it was 86 and 51 said yes. They had changed their major. So I need a Z-stat. I remember it's a Z-stat because we just showed it, but a test stat, really. I'm going to say test stat. Because remembering it's a Z is unimportant. I need that value. I need my p-value. And they gave me alpha is 0.05. You all ready? Melinda, you good? We are going to go stats, proportion stats, two sample with summary. And I wrote down my N1 and X1 and shit on the paper so I could just grab it directly there. X1 was 39. There were 80 females. There was 51 and 86 for men. And we were doing not equal to, which is the default one, which is nice. This is the thing that usually fucks students up. This symbol right here. They don't remember to change it. It's really easy to forget. You've gone through and written down everything else, it's easy to forget. So I've got a z-stat of negative 1.36. 4, if I do a third decimal place. And my p-value is 0.1727. So what am I doing here? What? Yeah, what's the next step?
Do not reject the
Why?
Because it's higher.
It's higher, yes. I'm making sure that it's just students will randomly, yes. I didn't think she was, but I wanted to make sure every other student knew why she was picking that. This p-value is higher than alpha. I remember p-val too low, reject the hoe. P-val is not too low, it's greater than, so we're not going to reject the hoe. Do not reject H naught. Do not support HA. I strongly recommend you do this for each thing. Write down that thing, not just the statement of conclusion. Because I can't tell you how many times students skip over writing this shit down. And their statement of conclusion does not match their results up here. So I don't know what part they didn't understand, and I got to mark off a lot on the file. If you got this part right and you fucked up the next step, then I know you just misread something. So it's always worth it to write down either this or the other one, where we reject H naught and we support HA. We're not supporting HA. HA was that they were different. So we can't support there's a difference. There is insufficient evidence to support the student's claims. That the proportion of men or women, females and males that change their major is different. Any questions?
So you're saying in the final you're gonna have like a stat crunch thing where it pops up, and then we have to write everything with the HO and all those things.
What you're gonna have is you're gonna have the black paragraph at the top and this green writing right here. The test stat and p-value will be listed. I don't have alpha listed, but it's usually either written up here as a specific value, and if it's not, the default is 0.05. So you'll have the black and the green. Your job.
I'm sorry, can you go through the stat crunch again one more time?
Yeah.
Please.
So you'll have you're gonna do stats, proportion stats, to sample with summary. Unless there's a data table, and then you do data.
We are going to be using stat crunch.
For the final, no.
It's already going to be given. Oh.
I'm going to give you she's asking right now for me to show it again.
Yeah, that's right.
Sorry. Are you good with the?
Yes, thank you.
Okay. So the final, you'll get like the problem, which is the black paragraph. You will get this like I will say test stat. I won't say Z or T or F, or sometimes students like memorize that and it tells them which test it is, which is not like defeats the why. You should be able to read it from the problem. You'll get the black paragraph, you'll get the test stat and the p-val. The test stat doesn't really help do a lot for you because you're like, I don't give a shit, but it's part of the process and it's something you would report in real life. The p-val is what you're going to use to make your decision. You have to go through the problem and go, what type of problem is this? Are they talking about proportions or are they talking about means? Where's one group, or is there two groups, or is there more than two groups? Is there three or more? And you'll look at the problem and break it down to that, and that will tell you what H0 and HA are.
So if it's two or more groups, it's always going to be a two sample proportion. Two or more samples.
If it's two groups, it's this. When we have three or more, that's when we start doing chapter 12 and 13.
Okay.
So two groups is a specific thing. Three or more is after they get once they hit three or higher, they're like, fuck it. 3, 4, 5, 6. It's all the same test. And you'll see the way they do it. It works. For these, it's very particular. So you'll tell me, like on the final, if you had this word problem and that stuff, what I would be expecting you to say is, this is a 2-sample proportion test. You get to pick how you label the groups. So label, like we did, P1 equals females, P2 equals males, but if you did it in the other order, that's fine. As long as your H0 and HA match. Then you'll say H0 is P1 minus P2 equals 0. HA is P1 minus P2 does not equal 0. You'll have the p-value already. You'll have alpha. At that point, I recommend going, the p-val is 0.1727 is greater than 0.05 alpha. I do not reject H0. I do not support HA. HA is the proportions are different. There is insufficient evidence that the proportions are different. I wrote that twice. And you should probably say what it's about. Are different between females and males. The way I had it worded up here is a little bit better. But that's kind of like what I'm expecting.
So when it's low, it's going to be the risk.
Yeah, when it's below or less than, you'll say there is sufficient evidence. And this will say support HA, and this will just say reject H0. I strongly recommend all of these steps. You'll get a point, like you get a point for doing this part. On the groups with two, you need to label them, so you get a point for that. You get points for telling me what H0 and HA are. You get a point for telling me what the decision is. Rejecting H0, but it's the same. He's laughing. It's the same process for all the tests. The only step that's different is this step right here, the starting step. And you didn't need StatCrunch. You didn't need to write down what N1 and N2 is, or X1 and X2 is. Generally, if it's something like this, where if it's one-sided, I will indicate. It doesn't. I gotta look at a word problem later on. Like an example. We'll do a practice final exam too, where I will give you the practice ahead of time on Canvas. You can try it on your own. And then I will go over in class, give you strategies for passing it. I want you guys to pass, but you got to earn it. It's doable. You got any questions?
So is our homework still due tomorrow for chapter 10, or are we like knowing those dates? Or I don't know. I didn't understand the message.
Chapter 10 should have been done to, let me check. No, I moved chapter 10 to next week out of the mercy of my heart. What?
I said 419.
Yeah, I changed it today. And chapter 11 is next week also. We'll finish chapter 11 on Thursday. All right?
You're gonna be uploading with me.
Yeah. That's all I got for you.
I'm waiting for you to tell us the GTS out.
It's kind of awesome. Getting prompted for it. All right, I will see you guys on Thursday. Peace.